Okay, so now we have two chloride atoms. That's why we have written chloride twice. Okay, so let's now write down the electronic configuration of magnesium. What is the electronic configuration of magnesium? It's 2A2. Atomic number as 12. So now how many electrons is it having in the outermost shell? It's having 2 electrons, isn't it? Yes. So 2 electron, just a minute. So yeah, so it's having 2 electrons in the outermost shell. So we'll make 2 here, 2 crosses here. Okay, then we'll put an addition sign because they both are getting reacted with each other. Chloride. Now we come to chloride. What is the electronic configuration of chloride? We all know about chloride. Chlorine is having 287. So how many electrons is it having in the outermost shell? It's having 7 electrons, isn't it? Yes, till now everyone is clear.
Yes.
Okay, very good. Okay, let's again make the outermost electrons in the chloride atoms. So 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. Okay, so one electron will go here and one electron will go here, isn't it? The family was incomplete here and the family was also incomplete here. So now magnesium has fulfilled their family and also he is also satisfied and chlorine is also satisfied. So let's now write the product. So what is the product? Product will be MgCl2. Everybody is knowing about that, isn't it? So tell me, what will be the bonding in then? Cg and Cl, yes or no? See, Mg is like here, one here, one here. It's having 2 outermost electrons. Okay, chlorine is okay. Chlorine is sharing here like this. Okay, a bond is there in this direction, and one more chlorine is here. Cl 1, 2, 3, 4, 5, 6, and 7. So it's sharing like this. Okay, so you have to draw a similar structure like this in your examinations as well. Okay, so let's make the structure, the product one. So how do we make them? We all know, I've already told you in one of the examples. So Cl, first of all, Cl, it's having how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. Okay, and out of them, one is of magnesium. A cross is there. Okay, let's come to magnesium. Now magnesium is having a 2 plus positive charge, isn't it? Because it has given out 2 electrons. Now it's free of 2 electrons. It's positively charged now. Okay, and let's talk about chlorine again. Chlorine is bonded here again. 1, 2, 3, 4, 5, 6, 7, and the last one is 8th one, which is the magnesium one. Okay, and what is the power on them? A minus charge, and here also a minus charge. Or we can write them as, or we can also write them as Mg 2 plus charge is there, and we can write Cl 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then a minus charge and whole twice like this. We don't need, here we don't need to make them twice like we have made here. Okay, is it clear, everybody? Can we move on to the next compound? Next compound now, guys, that is CaO, that is calcium oxide. Okay, calcium. Here also we are having 2 atoms, calcium and oxygen. So let's make calcium and here oxygen. Tell me what is the electronic configuration of calcium? It's 2882, and oxygen it's 2 and 6. Now don't think that here 2 electrons are there. Duplet rule, according to the duplet rule, its valency is fulfilled. No, duplet rule is only valid for helium, no other elements. Okay, it wants to get rid of this 2 electrons, that is, it wants to become +2, and this wants to become -2 by gaining 2 electrons, isn't it? So it will have, let's make it +2 so that when it gets added to it, it will form an octet, and here we'll write a negative sign so as to show that it wants to get rid of this. So calcium is having 2 so 2 electrons in the outermost shell. So 1 and 2. Okay, making of oxygen 6 are there, 1 2 3 4 5 and 6. So 2 spaces are left in the family to settle. Okay, so they are coming to the family, a new family. Now what has happened? Calcium is also happy because it has lose 2 electrons, and oxygen is also happy to get 2 more electrons, and their family is now fulfilled. So what will be the product we will be getting? We will be getting calcium oxide, CaO. So tell me, what will be calcium's power now? It will be -2 or +2? Free of 2 electrons. It's positively charged. And talking of oxygen is having 1 2
-2.
3. Yeah, it's having -2 because it has gained 2 more electrons. So it's having more electrons than the number of protons. So it's negatively charged, -2. 1 2 3 4 and then 5 and 6, and it's having a charge of -2. Is this whole thing clear to you? Properties. Okay, let's move on to some characteristic property. Akshay, please pause. So now we are going to discuss about some characteristic properties of electrovalent compounds. Okay, so some characteristic, very important, often asked in the examination, characteristic properties. Okay, so here we discuss about some categories. Some categories are there. The first category is the state of existence. That is, how do they exist? Now tell me, here what is the bond? A positive and a negative, isn't it? So positive and negative attract each other, isn't it? And there is a very strong bond, very strong. Okay, so now tell me, how will they exist? Which form of matter is having the strongest bond? Solid, isn't it? Solid having the strongest bond. So the first category is state of existence. State of existence, I've already told you they exist as solid. Secondly, that is melting and boiling point. We'll come to each one of them in detail. Okay, melting and boiling point. Okay, and the third category is conductivity. Okay, and the fourth and the last is ionization and dissociation. And dissociation. Okay, so now let's come to the first one, that is state of existence. They are very tightly packed, very strong bond is there. Okay, now we'll write that they are usually crystalline. Okay, so they are crystalline solid. If I give you an example, have you ever seen a raw NaCl? That is like a stone, yes or no? The salt which we are having, that's like a stone. It is grinded into fine powders which we see inside our house. Yes, and that's crystalline solid. So if anybody asks in the examination, if you are asked a question that why are they crystalline solid, so you'll write because of the presence of strong electrostatic force of attraction. I've already told you in the beginning that what type of attraction is there. See, what type of attraction is there? Electrostatic force. Okay, so because of the strong electrostatic force of attraction, they are what? Tell me. They are crystalline. They are oppositely charged. That's why they have a very strong bond and they hold together with a very strong attractive force. Now secondly, melting and boiling point. So they are very tough, very solid. Now tell me, is it very easy to melt or boil a stone which is very hard? No, it wants a very high. Yes, so melting and boiling point will be high or low?
Very high.
Yes, absolutely clear. So ionic compounds have a high melting and boiling point due to the presence of The same reason follows here also, due to the presence of the strong electrostatic force of attraction, and hence requires a large amount of energy to break the crystal force. Okay, so it is having a high melting and boiling point. Okay, we are coming to conductivity now. Are they a good conductor or a bad conductor? Metals are good conductor
Good
or a
conductor.
bad conductor? NaCl, a salt?
Good conductor.
Yes. So yeah. So now there is a very wrong, thing which you are saying just now. It's not true. They are a very bad conductor. I'll tell you the reason. Okay, they are a bad conductor. Why are they bad conductor? They are bad conductors of heat and electricity in solid state,
Solid
because
state.
they are solid. They don't have any free ions to move. Okay, and they are having a very, again the same reason here, that they are having a very strong force of electrostatic force. Okay, and that's why they don't have any free ions to move to conduct electricity. However, when these are dissolved in water, yeah, but a good conductor in
Molten state.
aqueous. Okay, in aqueous solution. Okay, where ions become free to move and conduct electricity. Here only comes ionization and dissociation. Okay, so ionization and dissociation, so ionic compounds when dissolved in polar solvents like water. Everybody knows that water is a polar solvent. Yes, it makes two different poles, a negative and a positive pole. So when it is dissolved in a polar solvents like water or melted at a high temperature, this dissociates or ionizes into its corresponding ion. So yes, it does dissociates and ionize in their corresponding ions. This is because the polar solvent like water decreases the electrostatic force of attraction. Okay, in every reason you were saying that there is a very strong electrostatic force of attraction. Now, due to this, the water which is there, it weakens. Okay, it weakens the strong electrostatic force of attraction. So it weakens the strong electrostatic force of attraction, resulting in the formation of free ions. Okay, when electricity is passed through this aqueous solution, the ions move freely and electricity is conducted. Is it clear? Now there is a small note, a very important note actually. So now ionic compounds cannot be dissolved in non-polar solvent. Water is a polar solvent, but cannot be dissolved. So water was what? A polar solvent, but cannot be dissolved in non-polar solvent. Okay, like what? Like, tell me what is an example of non-polar which is having no power at all. Okay, so like organic compounds. Yes, organic compounds, what we see,
Methane.
all the valencies of carbon are filled. Yeah, all the valencies of carbon are filled. They are not having any polarity, isn't it? So that's why these cannot be dissolved in a non-polar one. Now we are completed with electrovalent compound. Now we are moving on to the next compound, that is covalent compound. Akshu, please just stop. Please start. So now we are going to start covalent compounds. Okay, covalent bond. So what was the major thing we saw? What was the main thing which differentiates covalent from electrovalent? The main feature is that covalent compounds are formed by sharing, and these were formed by transfer. Can you see? They were formed by transfer, and these are formed by
Sharing.
share. Yeah. So let's write down the first and the most important point, that these are formed by mutual, okay, a mutual sharing, okay, sharing of valence electrons. Valence electrons. Please note every word here, everything you have to mention in your board. Sharing is a very important word. Valence electron is very important. People write that they are formed by sharing of electrons, but sharing of valence actually, okay, the outermost shell ones. Now, between the combining atoms of the same or different elements, now the compounds formed by mutual sharing of electrons are known as covalent compound. We all know. Now see, there are different types of covalent bond. Okay, so covalent bond also can be broken down into three types. That is a single covalent bond. Okay, what else can it be broken down into? It can be broken down into
Double covalent and triple covalent.
double covalent bond, that means double bond will be there, and then triple. Those who have studied organic chemistry must be knowing about these things, right? See, one bond is called ane, two bonds ene, and three bonds ine. Yes, so triple covalent bond. So this is not organic chemistry. Please don't mix it with that. I'm just giving you an example. Okay, so now this is formed by sharing of only one pair of electrons. Okay, pair means what? One electron, like two compounds are there, A and B. Okay, one electron A will give and one electron B will give, and they will share it. Okay, there is no way that B will take A's or A will take B's. Okay, they both are actually fooling themselves. Okay, he is saying that let's become stable, let's become friends. I will give you my electron, but he is not giving his electron. And he is also very clever, B is also very clever, he is also saying that I'll give you my electron, but he is not actually giving it. They both are fooling each other. They are saying that I've given it to you, we are stable now, and they are actually stable by sharing. Okay, is it clear? So let's take an example of a single covalent bond in which only a single pair will be there. Okay, see, single covalent bond, two pairs will be shared. In double covalent bond, what will be shared? Single, we saw that one pair of electrons was shared. In double, two electrons will be shared. One bond is this and the other bond is this. Yes, and in triple, how many? 1, 2, 3, 4, 5, 6. Three bonds are shared. Okay, I'll give an example of each and everybody. So let's come to the first one, that is the single covalent bond. So single covalent bond, the perfect example is a chlorine atom. Okay, a chlorine molecule, not an atom. Okay, so can chlorine exist like this? Have you ever seen a chlorine like this? No, it can only be formed if it is having Na with it or any other compound which fulfills its valency. But we must have seen many a times that it's written as Cl2, isn't it? Yes. So how is this Cl2 formed? Let's discuss that. So Cl2. So in this chlorine, everybody knows the electronic configuration. We have just read it. So electronic configuration of chlorine is what?
287.
7 and 287. So how many electrons it's having in the outermost shell? 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, and it's also having 1, 2, 3, 4, 5, 6, and 7. Now they both will share the one electron. Okay, it is wanting one electrons to get stable, to maintain their octet. So this chlorine has given one electron, shared one electron, and this also has shared. They both have shared, not transfer. No transfer is here. No transfer is here. No khichachani, only sharing. Okay, sharing is caring. So this is how a chlorine molecule is formed. So there is only one pair of electrons being shared. Yes or no? So it is a single covalent bond. Is it clear? It's a single covalent bond. So they can be written down as this also. Okay, is it clear? This shows a single bond. Is it clear? Is it? We can just write it as Cl2 molecule. It's a molecule now. It's not an atom anymore. So in this we can take this, and it also can exist independently. So let's make the oxygen molecule. So oxygen 1 and oxygen 2. Oxygen is having the electronic configuration of 2 6. Okay, 2 6 and 2 6. So 6 electrons in the outermost shell. Let's make it. Let's make it, guys. So okay, so 1 2 3 4 5 6. Okay, is it clear? So let us just make it more nicely. So yeah, and 1 2 3 4, 1 2 3 4 5 6 5 6. Okay, 6 electrons we have made, and these two will share with each other. They are wanting 2, isn't it? They want 2 in order to get stable, isn't it?
Yeah.
Because it's 6 and 6, they want 2 to get 8. So they this one has given it 2, and this one has shared his 2. So they both have shown the world that sharing is actually very caring, and they can get stable with the help of sharing. So we can just write it as O double bond. Here 2 sticks will be made, 2 strands. So O double bond O, or we can write it as O2 molecule. Clear? Let's move on to the triple talaq. No, not triple talaq. We are moving on to triple covalent bond. Okay. So triple covalent bond, in this 3 covalent bonds will be there. Let's take the example of nitrogen. Very important. Very, 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 very often asked. In fact, in every board exam it's asked, as I've seen. Okay. So nitrogen. Nitrogen molecule. How is it made? N2, we must have read it and wrote it down many a times, but let's see how is it made. So nitrogen and nitrogen. Tell me the electronic configuration. Electronic configuration of nitrogen is
2 5.
2 5. Okay. So 5 electrons in the outermost shell. Okay. So 1 2. Let's make it more clearly so that it's visible, absolutely clear. So 1 2, and then 1 2 3, 1 2, and then 1 2 3. Okay, so in order to get stable, it wants +3 +3 to get 8, isn't it? Isn't it? 1, first of all, it wants 3, 1 2, and then 3. It has taken 3, isn't it? Now it has become N triple bond. So 3 strands, 3 sticks will be there, or N2 molecule. I hope that everybody is clear with it. Yes or no? Very good. We are moving on to some conditions, as we have read some conditions in electrovalent. Covalent. Oh no, covalent also has some conditions. Okay, some conditions are there. So conditions, I'll just write them. The reason you can just find out on yourself. You know that ionization potential is inversely proportional to tendency to lose electrons, and electron affinity is directly proportional to what? To gain of electrons, isn't it? I've already told it, so I'll just write it. You all take out the reason on your own. So now here, how many electrons we want in the outermost shell? At least we want how many? See, in every one we are having at least 4, isn't it? Not less than 4, otherwise that it will not be formed. Otherwise transfer will be done. Okay, so we want how many electrons in the outermost shell? We want
At least 4.
at least 4. So this is the condition, 4 electrons. Okay, in the outermost. Okay, so just a minute. Okay, at least 4 electrons, okay, required. Second condition follows that it should have high electronegativity. third, high electron affinity, fourth, high ionization potential. Okay, and then in that we have read that electronegativity difference should be high, isn't it? Should be high, but here is it's a slight change that electronegativity difference should be
Low.
0 or negligible. Yes, so let's see what we have written there. So in the conditions we have written that it should have, see, large electronegativity difference, yes or no? But in covalent we have written what? Chalo, so let's move on to the next point. The next point we will be discussing about the electron dot structure as we discussed in electrovalent compound, isn't it? So let's discuss some of the electron dot structure in these also. So electron dot structure, okay, of covalent. So let's start. First of all, we'll discuss about hydrogen. So hydrogen, everybody can make it on themselves only. Hydrogen and hydrogen, it is having only one electron. They both will share, yes or no, and we'll get hydrogen or hydrogen molecule. Everybody is now expert as doing in doing it, yes or no? They know where to make one bond, triple bond, and double bond, isn't it? Everybody is getting everything in the taught in the class or not? Let me know in the comment section. Those who are watching on YouTube and those who are watching here, tell me, is everything clear?
Yes, sir.
Okay.
Yes.
So now moving on to second, chlorine molecule. Okay, so let's write it as Cl only. So Cl2. So Cl, we know the electronic configuration. What is the electronic configuration? I will not write it here. Let's make it as simple as we can. Yes, we have 7 electrons in the outermost shell. So 1 2 3 4 5 6. Okay, and 1 7. 1 2 3 4 5 6 and 1 7. So this and this will share themselves and they will become Cl2 or Cl bond Cl. Okay, let's move on to the next compound. See, we are so pro at this. Okay, we are not a noob anymore, we are a pro at this. So nitrogen molecule N2, everybody knows, I've already told it, yes or no? N 1 2 1 2 3 and 1 2 1 2 3. So this is a 3 electron sharing, that will be N triple bond N or N2 molecule. Okay, very good class, good going. Fourth one, water. Water is very often asked. H2O. So H2O, how to make it? H we know, H we know, O we know. Okay, so oxygen we are having 6, 1 2 3 4 5 6. Okay, and hydrogen we are having 1, we are having 1. So hydrogen bonds, so hydrogen will take 1 of oxygen and 1 of oxygen. Okay, both are stable. Hydrogen is having 2, it is having an electronic configuration which is nearest to the noble gas. Which one? Helium, isn't it? And oxygen is having what? Oxygen is also stable because it has got 2 more electrons. It has shared 2 more electrons, isn't it? So this is the electron dot structure very often asked. So we'll make it how? We'll write it H. Tell me how, what is the bond here? What is the bond here? And what is the bond
Single
here?
bond.
A single bond. Single bond. So hydrogen, single bond oxygen, single bond hydrogen. Okay, simple. Simple. The basics needs to be there. H2O molecule. Okay, so let's move on. We are moving on to ammonia now. Ammonia, that can be asked because it's a chapter NH3. We'll be doing it. Very, very interesting chapter, very easy chapter. Okay, very scoring as well. So electronic configuration of ammonia is N is having what? N is having 2 and 5, and H is having 1. Okay, is it clear? So let's make it. So how will it be? N and H. Okay, so now see how many H's are there. Tell me how many H's are there. 3
3.
H's are there. So
Yes.
N 3 H's make anyway. Make it anyway, but if you'll make like this, it will be easy to share it. How many electrons N is having in its outermost shell? It's having 5 electrons. So one will be shared with one hydrogen, one will be shared with one hydrogen, one will be shared with one hydrogen. And how many will be left? 2 will be left. 2 make it here. And then hydrogen 1, hydrogen 1, hydrogen 1. Make a bond. 1 bond, 2 bond, 3 bond. Very easy. We are pro at this. What is the formula? H3 or N dash H dash N. Okay? No, okay, it's totally wrong. So we'll make it like this. H.
Wrong.
N. Yes, I know. Don't shout. Okay, clear? Is it clear?
Yes, sir.
Yeah.
Okay. Let's move to the next 2 more covalent compounds. Very important, very, very often asked. This one is super important. Okay. The next one is CCl4. What is this? How many chlorides are there? Tell me. Yeah, 4 chloride are there. So it will be called carbon to carbon, one only carbon, and tetrachloride because 4 chlorides are there. So carbon tetrachloride. So carbon tetrachloride will be having how many chlorine is it having? It is having 4 chlorine. Okay. So what will be the structure? C, how many chlorines? Cl1, Cl2, Cl3, and Cl4. 4Cl, it is having 4 chlorine. Yes or no? That's a tetra. So let's make the electrons. How many electrons carbon is having in its outermost shell? We all know that carbon has a very special feature of tetravalency, isn't it? It's having 4 as its valency. 4 number of electrons in the outermost shell. So 1, 2, 3, 4. Each one will be shared with each one of chlorine. Okay, so one chlorine, and one chlorine, and one chlorine will share themselves. Share, and share. Is it clear? And chlorine is having how many electrons? We all know, I don't need to repeat them again and again. It's having 7. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, clear? Clear or not? What will be the
Yes, sir.
bond?
CCl4.
Cl. Yeah. So it will be CCl4 or C is in the middle. Cl, 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 and Cl. Very good class. Very good going. So let's move on to the next and the last type of covalent compound which we have to study in our syllabus, that is a methane one. We'll study it in organic chemistry as well. CH4. So how many hydrogen is it having? It's having 4 hydrogen. So make a single isolated. Isolation is very famous in COVID-19 situation, right? So a single isolated carbon is here and 4 Gunda Badmash hydrogens are surrounding it. Okay, so carbon is having 1, 2, 3, and 4 as this valency. Hydrogen 1, 2, 3, and 4. One is having hydrogen is having 1 in its outermost shell, so it will